Welcome back, everyone. In this video, we're going to start working on solving linear inequalities. In order to do that, we need to talk about interval notation first. So there are situations in math where we need to describe a set of numbers, like a continuous piece or pieces of the number line. And interval notation is one of the useful ways of making that description. So let's take a look at some interval notation. So first of all, given the graphs, this first one here on the left, this is the numbers bigger than 5. So we have a arrow with initial point at 5 and then extending to the right. And so this depicts the numbers that are larger than 5. The fact that there's a hollow circle here at 5 and on the next graph, there's a solid circle that indicates whether or not the 5 is included or not. If it's a solid circle, the 5 is included. If there's a hollow circle, the 5 is not included. How you would write this in inequality notation would be, in the first case, to say x is greater than 5. In the second case, it would be x is greater than or equal to 5, whether or not the 5 is included. When we're doing this, it's important to recognize that we're not just talking about the numbers 5, 6, 7, 8, and so on. We're talking about all of the numbers in between, too, all the decimals and fractions and irrational numbers like 6.28 and 7 and 3/16 and 8.0165, all of the decimals and everything bigger than 5. Or bigger than or equal to 5 in the second case. So what we want to have is a way of describing sets of numbers like this other than using this inequality notation, and that's what we're working towards. So let's finish these two pictures and then we'll do that. So in the next one, we have the arrow extending to the left. That would indicate the numbers that are less than, in this case, 6. So we have x is less than or equal to 6. Again, the solid circle indicates that the endpoint is included. For the one below, x is just less than 6. Okay. So one thing that can kind of complicate this is, depending on where you're going to school and when and what book they're using, is that the graphs here can look different depending on basically somebody's preference. So some people prefer to use, instead of the circles way of depicting this, they'll use either parentheses or brackets. And so you may see here, instead of a hollow circle of the 5, a right parenthesis. Sorry, that's a left parenthesis. And then the arrow pointing to the right. Again, to indicate that the point is included, instead they would use a square bracket rather than a round parenthesis. Of course, we're depicting the same set of numbers, just in a different way. We'll have a square bracket, a right square bracket, and then an arrow pointing to the left for the numbers less than or equal to 6. And then finally, for the numbers less than 6, there will be a round parenthesis on the 6 and an arrow pointing to the left. So square bracket for inclusion, like the solid circle, and round parenthesis for not inclusion, like the hollow circle. And in a way, this parenthesis bracket notation is useful when you get around to actually doing interval notation, which is right now. So in order to describe the set of numbers, we want to have a compact way of expressing this arrow, basically. To describe this, we might say, well, it's the arrow that starts at 5 and extends to the right forever, right? It keeps going up, 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 for all the numbers that are bigger than 5. So how we would express this is, we'll have a 5 and then a comma, and then the infinity sign to indicate that the set of numbers keeps going up forever and ever. Here, there's on the left side of the 5 a parenthesis, just like on the graph. That pair represents the numbers starting at 5 and going up to forever. If 5 is included, like the graph, we'll use a square bracket on the 5 side. And so it'll be 5 comma infinity for this one. Okay, for the arrows pointing to the left, at the left end of the number line is where negative infinity is. So on the left, we'll have negative infinity, and then a comma, and then in the first case, up to and including 6. That will be all the numbers less than or equal to 6. Next, negative infinity, up to, but not including 6. So a round parenthesis on the 6 side. Okay, it's important to remember that the whole number line extends between negative infinity and positive infinity. When you have a pair of numbers in interval notation, if a negative infinity is involved, it will be on the left. A positive infinity would be on the right. It would be wrong to say things like 6 to negative infinity. That's wrong. Numbers in interval notation show up in number line order. So the smaller number appears on the left. If you write down things like 6 to comma negative infinity, you're saying that 6 is smaller than negative infinity. Remember, numbers go in number line order. So this is how interval notation works, where the set of numbers goes on forever, either towards the positive infinity side or to the left towards the negative infinity side. If the set of numbers has a fixed start and end, like on these graphs, then the symbolism is going to be a little different. So here in the upper left, we have the numbers between 5 and 8. So this would be, if we use the brackets, we'll have a left parenthesis at 5 and a square bracket at 8. And down below, for the left, we'll have a square bracket, and then on the left, and then a parenthesis on the right. In the upper right, we'll have a parenthesis on both. And in the lower right, a square bracket on both. And those indicate the inclusion or non-inclusion of the endpoints, just as we had before. Okay, how these four sets look using inequality notation. In the first case, we have 5 on the left. 5 is less than, and we frequently use x for the variable here. 5 is less than x is less than or equal to 8. So here the strictly less than is on the 5 side, and the inclusion up to and including 8 is on the 8 side. Next, we'll have 5 is less than or equal to x is less than 8. So here the or equal to is on the 5 side, but there's no or equal to on the 8 side. Here, we'll have 5 is less than x is less than 8. Neither of these have the or equal to in them because the 5 and the 8 are both not included. Okay, and the last one, we'll have 5 is less than or equal to x is less than or equal to 8. Both 5 and 8 are included. So how does the interval notation work for this? For this, since there is a finite start and end, there won't be an infinity sign. We'll just indicate where this set starts and ends. So we'll have 5 comma 8 for the first one, a parenthesis on the 5 side, a square bracket on the 8 side. Okay, down below, we have a 5 comma 8, square bracket on the left, parenthesis on the right. The 5 is included, but the 8 isn't. Okay, up top on the right, we'll have 5 comma 8 inside of parentheses. Down below, we'll have 5 comma 8 inside of square brackets because both the 5 and the 8 are included. Okay, so important things to know about working with interval notation. With infinity, a parenthesis is always used, just out of custom. Note that. So either a parenthesis is used with the infinity sign, always. That's important. And then numbers are in number line order. Okay, so we would always write things like 5 comma 8 and never 8 comma 5. The smaller number is always going to be on the left. Okay, and then it matters whether you're using a bracket or a parenthesis. Math is full of a lot of little picky things, and here's one of them. It makes a difference whether you're using a parenthesis or a square bracket. Okay, and then the other thing worth mentioning is if you look at these pairs, like this 5 comma 8, and you're thinking, well, is this related to how when you have in the XY plane, you go across 5 and then up to 8, and that's the 0.58 in the XY plane. It's not. It's not the same thing at all. This is a piece of the number line, just a chunk of the X axis, if you like. It's not that one single point in the XY plane. It's unfortunately the same notation to mean two different things, and context is going to make clear which one is discussed. If you don't really know what I was just talking about right there, that's going to be okay. We'll pick that up later. But for now, we just need to know that this pair of numbers is indicating a start and stop point on the number line. And we use that to describe sets of numbers for a variety of purposes, to show solutions to different kinds of inequalities, and also to show domains of functions when we get there. So that takes us to the end of our look at interval notation. If you have any questions on that, let me know, and then have a great day.